Right. So here we are being asked to find the domain and range of f of x using the inverse method. So remember, with the domain, if it's a fraction, you look at the fraction and then you say, for this fraction or fractional function to be defined, then it must satisfy all values in the real number line. Remember, we are dealing with real values, not imaginary or complex values. We are dealing with the real values here. It must satisfy all real values. But there has to be an exception here because it's a fraction. A fraction, if there is a variable in the fraction, that denominator should not under any circumstance, under no circumstance, it should never ever be a zero. Under no circumstances. You cannot have a fraction with a zero in the denominator and then being defined. So it means that here the domain will be all real numbers except a situation where the denominator is a zero. So the domain of f of x, it will be all real numbers except x plus 4 equals 0. If the denominator, which is x plus 4, is a 0, then this function will not be defined. X plus 4 equals 0 implies x equals minus 4. Therefore, r minus 4 is the domain. So we are saying all real values except minus 4. This means all real values except minus 4. Or you could present it like this. The domain could be presented like this. Minus infinity to minus 4 plus minus 4 up to infinity. Here, we are not using square brackets because minus 4 is not part of the domain. Minus infinity is just a symbol. It means the number goes on and on. It's an infinite number. It's a number. The moment you say I've reached this number, if I add something or subtract something, the numbers will shift to this side, okay? So minus infinity can never be enclosed or inclusive. It is always expressed using these ordinary brackets. So this union here, it means and. It is this plus this. When I say plus and I use the union, it's a set symbol, which means plus this set. So these are the two ways that you can present the domain. Now, how do you find the range? Range of f of x. To find the range of f of x, we have to find the inverse of f of x, then find domain of the inverse, which equals the range of f of x. We know how to find the domain. The domain is easy to find, but with the range, we are referring to output, which means that you have to substitute each and every number into the function to get an output. That is when you have an idea of what the range is. But here, because we are using the method of inverse, once you have found the inverse, you then find the domain of that inverse. The domain of that inverse is the range of the function. So that's how we get to the range of the function. So let's find the range or the inverse of that function. The inverse of that function would say inverse. We would say let y equals x over x plus 4. That is the inverse. That's how we find the inverse. Let y equals x plus 4. Then make x the subject of the formula. You make x the subject of the formula, or you solve for x. That is basically one and the same thing. So here, when you have this y over 1 equals x over x plus 4, remember, if you have one fraction on one side, on each side of the equal sign, you can cross multiply to remove the fractional part. You can multiply this by this and multiply this one by this, but don't horizontally multiply. Don't multiply horizontally. Cross multiply only. So when you cross multiply, this will be y times x plus 4 equals 1 times x, which is y x plus 4 equals x. When you cross multiply to eliminate the fraction, don't cross multiply and then horizontally multiply. No, just cross multiply. Now let's remove the brackets, because we have an x variable, we have an x variable here. We remove the brackets so that we can collect like terms, put the terms that are like together. So this will be yx plus 4y equals x. And then here, there's an x here, there's an x here. So we remove the x from this side. This is minus yx minus yx. We remain with 4y. And this will be 4y equals x minus yx. Why am I doing this? Or why are we combining the yx with the x? We want to put those terms that have a similar variable, like terms together, so that we can remain with only one x. Remember, we are solving for x. We are making x the subject of the formula. If we are making x the subject of the formula, it means our final answer must have 1x, not 2x's as it is. Now, how do I introduce 1x here? You factorize. In order to have 1x, I'll factorize here. So that will be 4y equals x, and then this will be 1 minus y. When I factorize, I say x into x once, so that will be the 1. The minus is this minus. X into y, x cancels, you remain with the 1. I put it there. Now I have 1x. I have to get rid of this. So I divide by 1 minus y both sides. I divide by 1 minus y both sides. So this is 4y over 1 minus y equals x times 1 minus y over 1 minus y. Cancels out. You have 4y over 1 minus y equals x. So this implies x equals 4y over 1 minus y. This is what we are being asked to find. We are being asked to find the value of x, or to make x the subject, which means that there should only be one x in our formula. So this is the only x. When you get here, you write this as f inverse of y equals 4y over 1 minus y. Change the y variable to x. So this will be f inverse of x equals 4x over 1 minus x. So this is the inverse of x. So this is what we are being asked to find. Once you have this, you make y, you let y equals that function. Then you solve for x, or you make x the subject. We made x the subject of the formula here. And this formula is in terms of y. We have to express the inverse in terms of y, and then change the y variable to x, so that we retain or maintain the original variable, which is x. Now we have the inverse. So from this inverse, we have to find the domain. So let's pause here, and in the next video, we'll continue to find the domain and ultimately the range.